Any contract has its own unique address that is generated at deployment. The contract address is generated based on the address of the creator of the contract and the number of transactions of that account, that is the nonce. It can't be calculated in advance. Address is a variable type and has the following members: balance, transfer, send, call code, and delegate call. Let's talk about payable functions and contract balance. A smart contract can receive Ether and can have an Ether balance only if there is a payable function defined. A contract receives Ether in two ways. The first way is by calling a payable function and sending Ether with that transaction. Let's try an example. I have this smart contract with 3 state variables, a constructor function, and 2 setter functions. This contract has no payable function. If somebody sends Ether to this contract, that transaction will fail. I deploy this contract on Ring B test network. So I select here injected Web3. There is no error, so I can deploy the contract. I press on deploy. The MetaMask window appears. I'm already authenticated in MetaMask, so I don't have to enter my password. I modify the gigaway here to 2. I want the contract to be mined faster, and I submit the transaction. This is the link to etherscan.io. Let's check the transaction. My transaction is pending. This is a contract creation, as we can see, from my user account, from my externally owned account, and we wait for this transaction to be mined. The transaction has been mined, so the contract has been created. This is the address the contract received. So this is the address of my new contract. And now from another account, I will send some Ether to this contract. So I copy paste the contract address. This is the contract address. I copied to clipboard. And from another tab, I open my Ether wallet website. Okay, I select here Ring B, etherscan.io node, send Ether and tokens. My account, my private key is inside a JSON file, an encrypted file. I select that file. My encrypted file must be unlocked with a password, so I enter the password. Okay, I've entered the correct password. My account has a balance of 6 Ether, and I will send 1 Ether to my new contract. Generate transaction and send transaction. This is a summary of the transaction. Yes, I'm sure. Make transaction. Now I want to check this transaction on Etherscan. So verify transaction. The transaction is pending. I refresh the page. This transaction is already in the memory pool where all unmined transactions are. And we wait for this transaction to be mined. And our transaction failed. This is what I expected. Why? Because I tried to send Ether to a contract that doesn't have a payable function. So my contract, this contract, can't hold a balance. Now let's modify this contract in order to hold a balance, a Ether balance. So first of all, I want to create a function that returns the contract balance. I want to see what is the balance of this contract. So function get balance. This function doesn't modify the blockchain. It's a read-only function. So it's a view function. public returns unsigned integer. The balance of a contract is represented in way, and that is an unsigned integer value. And now I'm gonna use something like that. Address parentheses this dot balance. This is how we get the balance of the contract. Address parentheses this means the address of this contract. And this member, every address has this member, is the contract balance, the balance of this address. So this function will return the balance of our contract. So we can get the balance. And now I will create a payable function. So function payable public. Okay, this is a fallback payable function. Fallback payable function. This is a fallback payable function because it doesn't have a name, so it's an anonymous function. We can have only one function like this. This function can't return a value and can't have any argument, but this function can have a body like any other function, can modify state variables and so on. It's important to create a fallback payable function if we want our contract to hold an ether balance. Let's have something here. Okay, I modify the location. This is just an example. So location equals, let's say, London. I will deploy this contract one more time on ring B test network. This is a new contract. Submit. And I wait for the transaction to be mined. Okay, this transaction has been included into block number. This is the block number and will be reflected in a short while. So the etherscan.io will refresh this page shortly. We already have two block confirmations, and now I'll send one ether to this new contract. This is the contract address. This is another address because it's another contract. I've copied the address to clipboard, and now back on my ether wallet, I modify here the address. I want to send one ether to the contract, generate transaction, send transaction. Yes, I'm sure. So view the transaction, and the transaction is already mined. As we can see, the transaction receipt status is success. Last time we had fail. Why this happens? Because our contract with this address can hold an ether balance. It has a payable function. So back to our Remix editor, let's load the contract with that address from the blockchain. So I need the contract address one more time. I copy the contract address, and back on my Remix editor, here I paste the address. I load the contract from that address. I think this is just to be sure. I delete all these deployments from here and I load the contract one more time. This is my contract. And I press on the get balance function. And we can see my contract has a balance of 1 ether. Of course, the balance of the contract is represented in way. These are ways. But if you make the math, this is 1 ether. Here we have 18 zeros. Okay, so back to the slide. We've just tested the second possibility. So a contract receives ether in 2 ways. And I've tested this just by sending ether to the contract address by an externally owned account if the contract has a fallback payable function defined. The first possibility is by calling a Payable function and sending Ether with that transaction. Let's test it. We go to Remix editor and I create a function here, function, let's say send Ether. It's just one example. My function is Payable. I can have as many Payable function as I want. Payable, it's public. It can be called from outside of this contract. And inside that function, we can, for example, modify something. Let's say price equals, let's say, 600. So I've added this Payable function, public function. I will deploy this contract on a ring-B test network. So deploy, submit, and now I wait for this contract to be mined. The contract has been already mined. This is the contract address. I copy to clipboard. And now back on Remix editor, I load the contract. And using this account, this ring-B account, this is from MetaMask. Yeah, if I open the MetaMask, I can see the account here. So the address starts with C7, so it's the same account. So using this account, I will send, so let's say 100 way. I sent 100 way. And now I call this function, the send Ether function, just by pressing this button here. The transaction must be mined. This is a transaction. I submit the transaction. I wait for the transaction to be mined. It's ready. The transaction has been mined. And now back on Remix. I load the contract from this address. This is my contract. And I want to check X balance. As you can see, X balance is 100 way. So our contract holds a balance, can hold a balance, and it received this 100 way by calling this Payable function by another externally owned account, an user account. Let's come to a conclusion. If a smart contract doesn't have a Payable function and somebody sends Ether to X address, that transaction will fail. If we want a smart contract to hold Ether, so to have a balance, we must define a Payable function and then we send Ether calling that Payable function. The other possibility is to create a fallback Payable function that is a function without a name, and there is only one, and an externally owned account, an user account, simply sends Ether to the contract address, and that value will be added to the balance of the contract. In the next lecture, I'll show you how can we spend or how can we transfer the contract balance to another address.